Lesson 13, video number 2. We're going to go ahead and see if we can finish up this whole lesson in this video. The first question, number 8, it asks us to use the half-angle formula to find the volume of cosine of 105 degrees. Now, the first thing I'm going to tell you is if it tells you to use a formula, use the formula, okay? So I'm looking at the cosine of 105, so I'm going to look at this thing right here, okay? I'm actually going to write that on my piece of paper. I'm going to use the cosine of x over 2 is supposed to be equal to plus or minus the square root of 1 plus cosine of x divided by 2. Now, how am I supposed to use the half-angle formula right here to find out what this is? Now, the first thing that you want to notice is I don't know what the cosine of 105 degrees is, okay? I know 30, 60, 90, 45, 135. I know everything on the unit circle. Okay? So maybe there's something to compare there. Okay? Maybe there's an angle measure that this is comparative to, that when I plug it into here in some way, I can identify this. So what I'm really saying here is the cosine of 105 should be equal to the cosine of x over 2. If that's the case, what should x be equal to here? Well, if this is 105 and this is x over 2, then I have taken and I have to multiply this by 2 to get x, don't I? Again, if I say 105 is equal to x over 2, if I say that these numbers are exactly the same, that means that x should be 210 degrees. Okay? So what I'm looking at here is utilizing this identity, I can then make the statement that the cosine of 105 is really equal to the cosine of 210 degrees over 2. But wait a second. I now know what x is. If I know what x is, I can use this identity right here. This is equal to plus or minus the square root of 1 plus the cosine of 210 degrees divided by 2. Wait a second. Let me move this over here. What's the cosine of 210? I know that one. Let me think here, because I never remember these. 210 is the same thing as 30 times 7. So it's 7 pi over 6. So on the unit circle, 1, 2, 3, 4, 5, 6, 7. And it's the x value here, so it's going to be a negative of, this would be radical 3 over 2, right? Again, 1/2 increasing for sign. So this would be a negative radical 3 over 2. So this is simply 1 plus negative radical 3 over 2. Okay, so I'm going to go ahead and write that down here. This is equal to plus or minus the square root of 1 minus radical 3 over 2 divided by 2. Okay? Again, I hope I didn't make any mistakes with this. Very quickly identifying the unit circle information. Okay, that's all I did was find this by looking at the unit circle. Okay? So, what's the deal with the plus or minus? Okay? Well, where is the cosine of 105 really? Well, the cosine of 105 is over here, isn't it? Okay, that's where cosine of 105 is. And cosine of 105 is supposed to be a negative, isn't it? Again, it's in this quadrant, so it's got to be a negative x positive y. Cosine is x, so it's negative. That means that I'm actually working with this being a negative square root of 1 minus radical 3 over 2 divided by 2. Why is that? Again, because this whole thing is supposed to be a negative number. And the crap inside the square root, it'll only give me imaginary if it doesn't add up appropriately. I'll say it again. The stuff inside the square root, if it's negative, is going to give me an imaginary number. And that's not okay. So, with that being said, this is acceptable for a final result for question number 8. Okay? Let's go ahead and move on. For question number 9, okay, I'm going to go ahead and draw the lines there. And the question is specifically asking me to evaluate the following trig functions. I want the cosine of alpha over 2. I want the tangent of alpha over 2. I'm not sure if there's any more. No, there's not. It's just the 2, okay? Given that I know that the sine of alpha is supposed to be equal to negative 3 over 5. Okay, not to mention, I have 180 degrees is less than alpha is less than 270 degrees. Okay, so I want to find these two pieces of information, provided I have this information. First things first, 180 degrees less than alpha less than 270 degrees. Where does that sit? Well, that's going to sit in 180 is here, 270 is here, so it's going to sit down here. And I hope you see where this is going. This is negative 3 over 5. It's a fraction, not a trig value that I know. It's a fraction. Okay, it's not radical 2 over 2, radical 3 over 2, 1/2. It's none of those. So I'm going to drop that perpendicular. make my right triangle, and once again, okay, create the 3, 4, 5 triangle, where it looks like both x and y are negative. Why is the 4 negative? How do I know that? Because it's negative x, negative y, okay? Again, this value right here will never be negative. The radius value will always be a positive number. So if that negative was sitting down here, you're still going to put it on the 3. Okay, so now I have my triangle. What is it asking me for? Cosine of alpha over 2 and tangent of alpha over 2. Well, I have alpha here, not alpha over 2. So what I'm going to do is I'm going to go back to my formula sheet. And I'm going to look at my half angle identities of cosine x over 2 and tangent of x over 2. I'm going to go ahead and write the cosine one down. Oh, wait, no, I'm just going to leave it up here. Okay, I have it right up here. So I'm going to utilize that. Cosine of alpha over 2 would be plus or minus the square root of 1 plus cosine alpha over 2. So what I'm going to say here is that if I'm looking for the cosine of alpha over 2, I know it's supposed to be equal to plus or minus the square root of 1 plus cosine of alpha divided by 2. Well, if that's the case, what would cosine of alpha be? Well, there's alpha. Cosine would be negative 4 over 5. So this would be equal to plus or minus the square root of 1 plus negative 4 over 5, all divided by 2. So then the last question would be, is this plus or minus? What would this be? Well, this is where we have to do very, very careful division, because that's all it is, okay? Where does the cosine of alpha over 2 sit? Where is alpha over 2? Well, I know alpha is between 180 and 270. So if I divide all 3 pieces by 2, what does that give me? That gives me 90 degrees is less than alpha over 2, which is less than 270, 135 degrees. Where is 90 to 135? Alpha over 2, this angle right here, is going to sit between 90 and 135. So it's actually over here. I'm going to go ahead and write that in there. This is alpha over 2. Okay, that thing right there is alpha over 2, meaning it's sitting in the second quadrant. Okay, is cosine positive or negative there? Negative. That means that this cosine of alpha over 2 should be equal to the negative case. Okay, and whatever this happens to be equal to is our answer. Again, you can simplify the inside stuff if you want. It's unnecessary. Okay, so that's cosine of alpha over 2. Let's go ahead and find out what tangent of alpha over 2 is. So I'm going to go ahead and write down the tangent, alpha over 2, and that's supposed to be equal to utilizing my identity sheet. Okay, I'm going to use the first one. Okay, I'm going to use the first one, that this is sine of x divided by 1 plus cosine of x. Okay, we could use the second one. It doesn't really matter. Now, let's go ahead and plug everything in, because I already know what sine of alpha is, and I did already know what cosine of alpha was. That was a negative 4 over 5. So I'm just going to plug those two numbers into this identity. Okay, so sine of x, or sine of alpha, these should be alphas, okay, is equal to negative 3 over 5. This is divided by 1 plus cosine is a negative 4 over 5. Now this one, because it's not in the radical stuff, we'll go ahead and simplify this very, very quickly. This will be 5 over 5, so it'll be 5 plus a negative 4, so it'll be 1 over 5 on the bottom. On top, negative 3 over 5, meaning that I'm just going to actually have a negative 3 here. Okay, and that'll complete that problem. So that covers example number 9. Let's go ahead and look at example number 10. So example number 10 is one of the verify ones again. So I have 2 cosecant x cosine squared of x over 2 is equal to sine of x divided by 1 minus cosine of x. And again, the question is to verify this, number 10. How do I verify something that looks like this? Well, as I said in the last video, okay, every single trig function before I start doing anything major to this should have the same angle measure. This one does not. This is different from all the others, okay? So what I'm going to do here is I want to actually change this. I want to change it, okay, utilizing the cosine identity. So what I'm going to do is this. I'm going to do this as 2 cosecant x cosine of x over 2, that thing squared. Okay, that way I can easily replace cosine of x over, x over 2. Okay, so cosine of x over 2, replacing it with the identity. okay, I'm not going to show it again because we've seen it twice in this video already, is plus or minus the square root of 1 plus cosine x divided by 2. Now, why did I write the plus or minus in there? I wrote the plus or minus in there specifically because it's part of the identity, and I need it in there, okay? But what's nice about it is the fact when I square this, that plus, if I square the positive case, it's positive. If I square the negative case, it's negative. And if I square the square root disappears. So that gives me 2 cosecant of x times 1 plus cosine of x divided by 2. And now I'm going to go ahead and start simplifying this. Well, this is 2, and this is division by 2. They cancel each other out. I'm left with the cosecant of x times 1 plus the cosine of x. I'm going to distribute this through. Okay? When I distribute this through, that's going to give me the cosecant of x plus... Cosecant is really what? Cosecant is 1 over sine. So this is cosine of x over sine of x. That's really what? Well, this is then cosecant of x plus this would be cotangent of x. Okay? So we're supposed to prove that this is equal to this. How would I do that? Well, there's a number of different things I could do. Okay? The things that stick into me the most, I guess you should suppose the quickest, would be the fact that I'm going to multiply top and bottom of this thing by 1 plus cosine of x. Why would I do that? Because these are going to be conjugates. And on top, okay, you're going to notice that this will be, on the bottom you'll notice that this will be 1 minus, so I'll have sine of x times 1 plus cosine of x. This will be divided by 1 minus cosine squared x. Well, 1 minus cosine squared x, I'm going to go ahead and draw a line here so you know that I'm doing 2 separate sides, okay? With this side here, I have then sine of x times 1 plus cosine of x, and this is all divided by sine squared. Remembering the Pythagorean identity, okay, that sine squared plus cosine squared equals 1. Well, one of these will cancel out then. I'll be left with 1 plus the cosine of x divided by sine of x, which is equal to 1 over sine of x plus cosine of x over sine of x if I distribute the division. And I can stop right there because that's the same thing. Okay? That finishes the verify problem. We went over question 11 inside class, so we will not be doing that in the video this time around. That completes lesson 13, video number 2.